Hello everyone, I am Atish Bandar, a geotechnical engineer at Karnal Stantec. Today I'm going to talk about research work conducted during my PhD candidature at 3G Deep Research Group, Monash University, Melbourne. If I talk a bit about my background, I completed my bachelor's degree at Monash University, Malaysia, specialized in civil engineering. Afterward, I started my PhD at 3G Deep Group under the supervision of Professor Ranjit Pathegama. The 3G Deep Group of Monash University is headed by Professor Ranjit Pathegama, who is a fellow of Australian Academy of Technology and Engineering. With his leadership, 3G Deep Group consists of 10 leading researchers and well over 35 PhD students. The primary aim of 3G Deep Group, as I mentioned here, is to harness new and more sustainable forms of deep earth minerals and energy resources. We follow UN Sustainable Development Goals 7, 9, and 13 in all the projects carried out at 3G Deep Research Group. In 3G Deep Research Group, research works are carried out across a number of research themes such as geothermal energy, waste to wealth, CO2 sequestration, coal seam gas, shale and tight gas, hydrogen as a fuel, coal gasification, deep mining, and gas hydrates. Now, I will move on to talk a bit about the research work I carried out at 3G Deep Research Group. When conducting advanced resource stimulation techniques to extract oil and gas from deep unconventional wells, a rapid decline rate is often raised after a short time from its initial extraction if you compare it with a conventional well. Generally, production can drop by 85% within the first 3 years. Reason behind this significant production drop is the occurrence of major proppant degradation mechanisms within deep fractures such as proppant crushing and proppant embedment. Proppants. It is a granular substance. What we do in stimulation techniques is we inject proppants along with the fracturing fluid at a high pressure. So what happens is these proppants go in between fractures and keep the fractures open, withstanding high prevailing in situ stresses in deep underground. But these high in situ stresses cause proppants to crush or embed into the fracture, causing increase in the flow path tortuosity or reduction in fracture aperture, ultimately reducing the fracture permeability. So my PhD research focus was to understand these two major proppant degradation mechanisms, proppant crushing and proppant embedment. 3G Deep Group has developed unique experimental facilities in the 3G Deep Research Laboratory to conduct advanced experimental studies. Following are some experimental setups I utilized to carry out my experimental work. Let me now talk about my PhD work. I initially carried out a number of studies to understand the single proppant mechanical behavior. We performed micro-CT scanning coupled UCS testing on single proppants to analyze proppant microscale pore variations when they are subjected to higher levels of loading. Also, we studied proppant breakage mechanism using advanced experimental techniques. Furthermore, I used discrete element modeling numerical approach to understand single proppant mechanical behavior. We accurately calibrated and validated our discrete element models with our experimental studies, and then we used those models to understand fracture initiation, fracture propagation, and coalescence processes undergoing when propons are subjected to proton crushing and embedment. Later on, we further expanded our discrete element models to investigate proton pack behavior and proton pack rearrangement mechanism occurring when they are subjected to advanced loading environments. In addition, we also performed 3D synchrotron imaging, 3D fracture surface scanning, and statistical analysis techniques to understand the impact of fracture morphology and characteristics of hydraulically induced fractures on proton performance. Furthermore, we also carried out synchrotron imaging coupled long-term permeability testing on proton injector fractures to study the creep-induced proton embedment and time-dependent fracture permeability variation. The extensive research work I carried out at 3G Deep Group enabled me to publish and co-author a number of journal articles in renowned journals. I have been immensely fortunate to be a part of 3G Deep Group and work under the leadership of Professor Ranjit Pathekama. His undivided attention, his guidance, support, and continuous encouragement helped me to achieve success throughout my PhD candidature. Thank you.